Hello everyone, welcome to our pre-calculus lesson. This is lesson 26, some theories about quadratic functions. So this is about some couple of formulas that you have seen. Let's say quadratic formula minus b plus minus the square root of b square minus 4ac divided by twice a. How this formula comes or this and that. So this kind of thing related one video. This is short video. Then another we have another little bit elaborate one. So let's have a look. First one is, this is the agenda, like these different forms and how they are related to one another, this kind of thing. These are the agenda for this today's class, for this lesson. So first one is this vertex form and then a standard form. Actually we can interchange them, we can replace them from one another, and also we can find out the x-intercepts from the vertex form, even from here also. They, of course, they will give us the same answer. They will give us the same answer. If we want to find out the x-intercepts, then how it looks. We put y equal to 0, then we do some calculations to find out the x-intercepts. Then we have these two value for x equals to this and x equals to this. This is positive and this is negative. We have two x-intercepts from this vertex form. This is one example. Suppose if this is the function in the vertex form, what are the x-intercepts? We do the calculation and we have their x-intercepts. This is kind of somewhat theoretical way. And in the standard form, from the standard form, this is from the standard form, how do we find out the x-intercepts? This calculation is, of course, this calculation is also given in the book. This is something like x square a. First of all, divide this whole line by a, then bring some extra thing so that we can make a plus b whole squared here, this kind of thing, so that we can separate the x. You see, x is here and x is here, so that we can separate x. Here x is separated. Once x is separated, then the maths becomes easier. You send other things in the other side, then try to find out x equals to what, because there is like some square, so it will give us a square root in other side, including plus minus. Then you have this, you send it to the other side, you get our actual formula, minus b plus minus the square root of b square minus 4ac divided by twice a. You will not need this calculation always. This is just to show you how this formula comes. This is the quadratic formula, very, very important one. We use, this is the quadratic formula. This is the discriminant, and from the discriminant we can actually understand how many answer we will get from our question. If it is greater than 0, if the value of this b square minus 4ac is greater than 0, then we know that two answer will come. If this is equal to 0, then one answer will come. If this is less than 0, that means negative. Negative means undefined within the square root, or imaginary answer, that means no real answer will come here. This is example, as you can see. These are the example. And then we actually have solved this kind of math. These are the answers, just like from previous slide. This one is. So this is how this vertex form come, a into x minus h whole square plus k. And we use this h comma k as our vertex, and we said that our h, vertex x value, is minus b by twice a. Minus b by twice a. We said it many times. Vertex h value is minus b by twice a. This is how that minus b by twice a comes. You see, if we try to write this function ax square, fx equals to x square plus bx plus c, this part, if we want to write it in terms of vertex form, x plus or minus something, then something whole square plus something. Remember, a into x plus h whole square plus k. If we want to write it in that form, then this is the form that it takes. Basically, b divided by twice a comes here, and we know that in our formula, that formula, see, there is a minus here. So a into x minus h. So basically, this h will be minus b by twice a, because it is plus, but there is a minus here. Plus minus, answer is minus. Okay. So this is how our vertex x value, which is h here, becomes minus b by twice a, and k value is 4ac minus b square divided by 4a, but we usually do not use it, because once we know the x value, we can just directly put it here and we can get the y value. or k value we can get that way. K and y represent here the same thing. I mean, if we put the x value here, then we get the y value. Y value is the basically the k in this question. So instead of doing this calculation, we actually used the other method. So we said that we said this. We said find out minus b by twice equals to what? Then we said that then the other value, y value is f of minus b by twice n. F of minus b divided by twice n. Okay, so if we find out f of minus b by twice a, we will get the y value. And other way to find out that value is this. This is what I am trying to mean here. This and this will give you the same answer. This is just a theory. And just if anyone is interested, you will not need these calculations always. Even you may not need it once even. But those who are interested, this is actually the calculation, because if you want to see the theory or the things that is happening inside the maths, this is what the inside engineering is. Okay. So this is the same thing, vertex standard form. This one and this one, as you can see, exponents how they are related. This is their relationship. This is their relationship. Ax squared plus bx plus c. Then a into x minus h whole square plus k. This h and k represent this from this equation. This is how they are connected. And they will always give you the same answer. And here, square, completing square in picture. So this is x squared plus 4x plus 10. Can we write x plus something whole square plus something, or x plus a plus b whole square? Can we write it a plus b whole square from here? Answer is yes. Then what happens? See, inside the math, that 4x became twice x and twice x separated. Then from this 2, you see we need a 4 here to make a square. So 4 will come here from that 10. So it becomes like x squared twice x, then this is 4. 4 means 2 squared. 4 means 2 squared. So basically x plus 2 whole square. This is x plus 2 whole square. How do you know? This is x, this is 2. So x plus 2. And you see this side also x plus 2. So x plus 2 into x plus 2 equals to x plus 2 whole square. And then plus 6, some extra number. This plus 6. Look at this. This is how when you do some squaring inside, actually this is what is going on. In terms of, if you are a visual learner, this will be nice for you to visualize what happens when we do some calculations in the math. So this proof is related to area and the length of the sides of a rectangle. So when the area of a figure will be the highest, when it is highest. If you have some figure like this, for the same perimeter, when it will be the highest, area? That is the question. For the same perimeter. And actually the theory says that if the value of length and height is same, then it becomes the highest area, then it gives us the highest area. Okay. So maximum value is at p divided by 4, as you can see here. Perimeter divided by 4. If the perimeter is let's say 12, divided by 4 means 3. Not this one. Let's say this is 3 and 3. 3 and 3. So this is 3 and this is also 3. This is also 3. So total is what? 3 plus 3 plus 3 plus 3. Total is what? Total is total is 12. So all of them make total 12. And what is the area in this figure? What is the area in this figure? Area in this figure is 3 into 3, that means 9. And this 9 is the maximum area for this perimeter 12. Let me prove it. Let me show you a proof. Suppose how can we make it this side something different? Suppose if we write here um, 5 5 1 1. So total is what? Total is 12. 1 plus 5 6, 5 plus 1 6. So what is the area of this figure now? So total is 12. Here also total is 12. What is the area of this figure? Area is length into width or length into breadth. So area is 5 into 1, that means 5. So which area is bigger? Which area is bigger? This one or this one? Which area is bigger? So you see the area is bigger here, whereas their perimeter is same. So for the same perimeter, if the figure is square shape, then they will give you the maximum area. Then they will give you maximum area. This example is particularly useful if you buy if you try to buy some land. Then this figure is particularly useful. Just a minute. Let me see. Please, yeah. So this is the way that we can prove that for a square shape we will always have our highest area for the same perimeter if the perimeter is same. And then see, this is another proof: x square minus a square. If we try to break it down, then basically we are subtracting something from here. We are subtracting something from here. This is how it is always decreasing if we want to get some newer and newer length for the same picture. So in short, our square shape always will give us the highest area. This is the logical proof. So, and these are the some homeworks. We'll try to do some other maths also, and we have another video for a more explained way or more rigorous explanation is given in that video. You can have a look in that video also. I'll share both of them so that you can see both video at a time. Okay. So that's all for today. Thank you all. Thank you very much. Have a good day. Bye bye. See you all in the class.